If we want to become experts at something, then we need to learn to think like the experts. But how do we do that? Most people don't have any kind of plan or system for analyzing expertise, and that makes it hard to understand what it is that we should be getting better at. So I want to suggest one approach that you could take here, one way of thinking about the nature of expertise, especially the nature of problem-solving expertise. Now, it's going to start out a little abstract and, well, I think it's going to stay a little abstract, but I think if you stick with it and actually understand what I'm saying, it will be helpful in driving your learning forward. In this model of problem-solving expertise, there are 3 elements, plus one, which I will get to at the end of the video. The first element's pretty obvious. The expert knows how to do more things than the novice. An expert chef knows how to cook more dishes than a novice chef. The expert mechanic knows more techniques to fix car problems than the novice mechanic. The expert mathematician has more problem-solving techniques at their disposal to solve math problems than the novice mathematician. Let's call this the set of things that experts can do. It includes more than just problem-solving techniques themselves. It would also include things like information gathering techniques. So a mechanic knows how to diagnose problems more effectively, not just fix problems more effectively. So that's the first element, the set of things that we can do. Well, let's say our expert confronts a new problem that they've never seen before, one where it's not obvious what to do. They know how to do a lot of things, but which things should they do? This brings us to our second and third elements. The second element is about what ideas and actions come to mind when the expert sees that problem. Out of the total set of actions, ideas, perspectives, models, etc., let's just call them tools that the expert has at their disposal. Some seem more appropriate for the problem than others from the expert's point of view. The expert's feeling and choice about which tools are appropriate for a given problem is the second element of expertise. A novice is going to select a different set of tools from a more impoverished toolbox. But even if the novice had the expert's toolbox, they would still pick a less appropriate set of tools for the problem than the expert, because the novice hasn't yet learned how to map tools onto problems appropriately. What about the third element? Well, our expert has confronted a new problem and they've chosen a set of tools from their toolbox that would be appropriate for that problem. Now they have to decide how they're going to apply these tools. In the simplest case, this is just a question of deciding which tools or approaches to try first and which tools or approaches to try later. That is, it's just a question of sequencing. Perhaps we would try the approach with the highest likelihood of solving the problem first. Or perhaps we would choose an approach that is likely to yield a lot of information about the problem in order to help us decide what to do next. Or perhaps we would just try the easiest approach first. In more complicated cases, it is more about how to combine the chosen tools in a useful way. So it's less about sequencing and more about combination. So expertise in problem solving then is about the set of tools or actions that we have at our disposal, the selection or mapping of those tools and actions onto specific problems, and the application of those chosen tools to the problems in an effective way. But there is a final vitally important skill that expert problem solvers have, which is to generate, through interaction with the problem, some new idea, some new perspective, some new approach, some new tool. A good analogy is to reading a book. When you're reading a book deeply, you will be learning something through your interaction with the book. And it's not necessarily something that the book makes obvious or even wants you to learn necessarily. Maybe you learn that the author is making a really bad argument and you learn about the kinds of bad arguments that people can make. But because you and the book are working together, you gain some new knowledge or new insight. Now, is this the only way of thinking about problem-solving expertise? No, I don't think so. But even this simple model can help you to find gaps within your own skills. Let's say you and an expert solved the same problem. Well, when you look at how the expert solved it, it's not enough to just say, well, yeah, I guess I should have done it like they did it. Rather, you can ask yourself a few questions. Did they just have a tool that I didn't have? Or did I misunderstand the relevance of a tool that I already knew about? Or did they prioritize using a tool that I was going to get to eventually, but I didn't prioritize? Or was it something about how the expert interacted with the problem, what they learned from the problem through that interaction that I didn't learn? If you actually want to understand how this model works, write a comment where you try to apply this model to something that you're learning right now. The situation should look something like this. You tried to solve a problem and you got to see how an expert solved that same problem, and you didn't solve the problem like the expert did. Then you try to categorize where the gap was between you and the expert. Which of these 4 categories does that gap fit into? I'm going to give you some quick examples of me doing just that in a pinned comment below so you can check that out. Thanks for watching. I'll see you next time.